o'clock. So let's begin. So firstly, I would like to announce that today's session is in collaboration with Vasireti Venkatadri Institute of Technology. And I am glad that Professor Satyanarayan and Mr. Seshu has collaborated with ETG to conduct such session for the students. And we really appreciate mentors like you who encourage such programs for the students to make them aware about the latest technologies which are there and to make them ready for the future of electric vehicle engineering. So if Mr. Satyanarayan is there, I would like to have some words from you. Yes, would you like to tell something to the students, Mr. Satyanarayan? Yeah, you are mute. You are mute, sir.
Yeah, thank you, Mr. Rahat. We are very lucky and fortunate to have people like you readily giving the opportunity to learn about the latest technologies. And I appreciate your efforts. And I encourage our students to learn these things to apply them in their project works and also in their future endeavors. Not only from our college, and there are many people around the world are joining your programs and they might be benefited by you. And I congratulate you once again. And at the outset, I appreciate your efforts. Thank you.
Yes. Thank you very much. Okay, so let's. Sir, could you please mute yourself? Getting to code here. Please mute yourself.
Okay.
Okay. Yes. Thank you very much, sir. Okay, so I heartily welcome all the students from Vasireti Venkatadri Institute of Technology and all the other students as well for today's session. And yeah, let's begin with. So, firstly, let's see the topic of today's session. It's battery battle. So, we'll be seeing two different batteries competing with each other to be get into the electric vehicle, which gives the best performance for electric vehicle application. So we'll be this whole session will be focused on both the lithium ion and aluminum air batteries itself. So now let's see what is the overview of today's session. What exactly we'll be learning here. Okay. Yeah. So firstly, we will see what exactly battery is and how we can define the battery, what different categories of batteries are. Then specifically, we will go to the lithium ion battery, how exactly it works, what are the different properties of it, and what are the different cell chemistries available, how we can use for the specific application. Then we will jump to lithium ion batteries, aluminum air batteries, how exactly they work and what is the construction, how they are made, and how exactly the chemistries happen inside the battery when it works. Then we will try to compare both of them and we will try to find out the limitations of each of the battery. And on the basis of all these things, at the end, we will try to conclude which battery is very much suitable that we can put it into the electric vehicle and which will give the optimum performance and which will fulfill the requirements that electric vehicle requires for a battery. So all these things we will talk about. And before getting actually started, I would like to announce that this session, it will be two-way communication. It will be better if we have a two-way communication. So in between, if you have any doubt or any point that you did understand, or you want to, you have more idea, more clarity about that, you have worked with that thing, so you could just unmute yourself and we can discuss on it. And if you have any doubt, that also can be taken in between. Okay. So I will really appreciate if you guys unmute yourself and take part in a discussion. And at the end as well, we will have a good discussion as we will be having compared both the batteries. We'll be seeing both the batteries. So in the end, I guess more and more students will participate in the discussion. So yeah, let's begin. The first thing first, understanding what exactly a battery is. Okay, so battery is nothing but a energy storage system. So what energy storage system are like, there are different kind of energy storage system. We need energy, like universe is running on some sort of energy which is already provided to it. And there is a lot of thing to talk about energy basically, but what battery is, it stores the energy. So no matter what is the nature of energy, is energy could be of multiple types. Electrical energy could be there, mechanical energy, then chemical energy, thermal energy, potential energy, kinetic energy are also form of energy. So any system that stores energy of any form is called an energy storage system, and battery is a form that stores the energy in a specific chemicals. So that's what the we can say a battery we can categorize in. So we all know we require energy to do work, and to do any kind of work we cannot constantly get the energy from a source, or we cannot generate the energy from any source. Let's say we are using solar. So if we need some energy to be used at the night time when sun is down, and we need some energy, so how we can get that? So whatever energy we are getting from solar, we have to store it at some place that we can use it when solar cell is not working. And same goes for wind energy. Wind energy, if we are using to like uh, run our home appliances and all, but the time when there is no wind, so how exactly we can generate electricity? So whatever energy that we generated from the wind turbine, we have to store it somewhere, then we can use it when there is no availability of it. So that's how the energy storage system basically works. And we know work and energy are interchangeable. So whatever work we do, we get it converted into the energy, or whatever energy we have, we utilize it to do the work. So that's how the concept of energy works. But there are different types of energy storage devices we have invented yet. So battery is one of them. Then there is a fuel cell in which also we can store energy. There are supercapacitors, ultra capacitors as well. And there are some mechanical form of batteries as well. So these are like in a form of chemical we are storing energy. So there are mechanical batteries as well, like flywheels, gravity battery. Then so these kind of, like flywheel is also one sort of energy storage system we can call it as, because what happens when we give it energy, it keeps rotating, and when we require, we can get that energy from the flywheel. So that's the concept we use in an engine as well. In four-stroke engine, we have just one what we call it as a power stroke, and rest of the three strokes are like they are power consuming strokes. So that one stroke, it stores the energy in the flywheel, and flywheel provides the energy for the rest of three strokes. So that's power storage devices. The flywheel is also. So and even the food that we consume. Okay, so that's also one of the power storage device we can call it as, because it's giving us the energy. It has stored energy in it, and when we consume it, we get energy in ourselves to do the work. So like I am talking now. So power storage system. So that's what it is. So specifically talking about battery, defining it, it's a electrochemical device. Okay. So electrochemical means you might already got idea that there is some electricity and there is some sort of chemical chemistry. So it's an electrochemical device that converts chemical energy into electrical energy. Okay, or specifically it stores chemical energy, and which can be converted into electrical energy with the help of electrochemical reaction between electrodes. So in battery, there are two electrodes, basically cathode and anode. So the reaction happens between these two electrodes, and as a result, it generates like it supplies the energy to the external system. And again, it can be charged so that it can be stored inside the battery. So this is about the battery. Okay. So now let's move ahead with lithium ion battery. So before getting started with the lithium ion battery, firstly, as we are focused on what exactly, like at end goal of this session is to understand which battery we can be put in the electric vehicle. So firstly, we will list down the requirements, exactly what the requirements of electric vehicle battery is, what it should be. So whenever you try to design some system or product, you enlist the requirements of it, that it has to fulfill these many things. Let's say, for example, I am trying to design a system or a product that I want it to work as something that writes. So basically, I'm trying to design a pen or pencil. So I will note down the requirements of it, what exactly function it should perform, and what it shouldn't do, what it should do, and how how its design should be, how bulky it should be, how light it should be. So those are the things. So I just have a quick question for you guys. What qualities should electric vehicle batteries have? So if you guys know like what are different qualities, so just let's say for example I have a pen. So for pen, if I require pen, so what I will do, I will just need something which I can pick easily, drop, put it easily, which can fit in between my fingers, and it shouldn't be like it shouldn't harm my skin when I'm touching it, and it shouldn't be like its tip shouldn't it should not cut the paper when I'm writing it down. So all these things are requirement of a pen. So in terms of electric vehicle battery, if we think as a student or as an electric vehicle enthusiast, if you are, so what things you would require in a battery? Yeah, I see lot
Like
of
higher
mentioned.
density, higher density, higher power density per kg.
Yeah, exactly.
Also, safety is one of the most where a complete world is working
Talking about.
toward.
Hmm.
Cost is also one of the thing, and naturally materials.
Hmm.
Now materials are one of the important focusing,
Material shouldn't be like hazardous or toxic when they
and
are
it
like.
should be easily available.
Hmm. Yeah, great. Yeah, thank you very much for your responses, guys. We'll see what exactly are the requirements of electric vehicle batteries are. So firstly, the flexibility. So flexibility, there could be like availability of the material as well as the manufacturability of those material, and wherever we are trying to fit this particular battery, it should fit there. So that's the flexibility it should have. It shouldn't be like a very bulk or a huge structure kind of thing that we cannot put it in a two-wheeler application like that. So it should be flexible enough mechanically that we can design it in a different ways or for the different volume constraints. And another major thing is a safety, definitely. So safety could be in various terms: mechanical safety, thermal safety, electrical safety, multiple things would be there. So mechanically, it should be rigid enough to take the external loads, or some, if there are bumps or jerks are there on the road, it should be taking that, and it shouldn't blast while having the impacts. Then electrically also it should be safe when it's overcharged, so it shouldn't blast or something. And thermal runaway has to be considered while selecting the battery. Then it should be of high energy density. So energy density, what it means is it should store a lot amount of energy in a small volume. Then only we can get a high amount of range, and we can like run a vehicle for a, one charge we can run a vehicle for a long distance. So that's what the energy density means. And power density is something, it should give the power quickly. So it shouldn't be like energy density high but low power density. Like it stores a lot of amount of energy, but it's not delivering the energy as required at that particular instant of time. So it also should be delivering a large amount of power. So that's how the high power density should also be there. And voltages, required voltage systems which are being used in the vehicle, it should satisfy that. And also cost is a major concern when it comes to the Indian market. So cost is a thing that it should be available easily, and the manufacturability and extracting the material, it shouldn't be very costly in all terms. And the shelf life, so when battery is like not being used and it's just kept idle for a long time, so it shouldn't get discharged. Uh, a large discharge shouldn't be there. So it should keep like be charged for a long time. And operation life, so when it is being used, it shouldn't discharge quickly, and multiple cycles it should perform. So there should be around 10,000 cycles it should be taking. And yeah, and the thickness, like the definitely the mechanical for the mechanical stability, it should have a good casing thickness so that it can take the shocks and all, and it shouldn't blast quickly. Then commercial availability, the availability of the material. So if you talk about lithium is not available equally in all over the world. It's specific regions lithium is available. So availability of the material is also the concern, and the temperature range in which it's being operated. So if you go in northern countries or European countries, there are like temperature is always below 10 degrees Celsius. But in India, if India and eastern countries, if you talk about, so the temperature is more than 25, 30, 40 degrees. So the temperature also has to be taken care of. Like the battery should be operated within a wide range of temperatures, and it can be operated in different regions. And life cycle, yeah, we already talked about that. So uh, these many things are required for electric vehicle battery. So whenever when we will be talking about the lithium ion cells or the aluminium air batteries, how it works, what advantages they bring and what limitations they have, so we'll be considering these points and we'll be judging on the basis of these points which battery is like giving a better performance, which is fulfilling this requirement, and on the basis of that we will try to get the conclusion which can be best suit for electric vehicle application. Okay, so if you have any doubt in between regarding these terms, you could let me know, or we shall move ahead.
Go ahead, sir, but again, let us see a couple of alternative things. What is
Okay.
really being done in India?
Yeah, sure, definitely. Cool. So as we have seen the requirements of EV batteries, now we will talk about our first candidate, which is a lithium-ion battery. So you lithium-ion battery, you might be hearing this term a lot nowadays, and like it's all the application that we have been using lithium-ion batteries only, whether it's our mobile batteries, laptop batteries, or any appliances that we use. Majorly, there are lithium-ion batteries only. So why exactly we are choosing lithium over other elements, and what is the reason for like having the lithium as a primary element in the battery? Do you guys have any idea the specific reason for using the lithium?
Because it meets all your defined properties in earlier slide. It is better than the
Mhm.
available materials, what is readily. Maybe this is a new invention, and
Yeah,
because
that's the thing. That's one thing. But there
Also,
is
it is rechargeable. It is a
Lithium is
secondary
highly
side.
reactive and the lightest metal in periodic table.
yeah, yeah, exactly. So
Lithium-ion battery have high DOD.
depth of discharge, yeah, exactly. So yeah, we will see why exactly lithium is standing out of other elements and why we are choosing it. So as someone said, it's the lightest of all metals. So being lightest, it means it can store more energy with a less weight. So that's why the lithium is chosen. And then the very important thing is it's the greatest electrochemical potential. So the electrochemical potential, do you guys like it's a 11th, 12th class chemistry if you know. So do you know what exactly the electrochemical potential is? Lithium has the highest electrochemical potential, and that's the only reason, one of the key reasons we are using lithium as a battery material. So does anyone know what the electrochemical potential means? Because that's the key term here for using the lithium.
But it's the like potential to lose or gain electron. So like lithium can lose electron very easily.
Exactly, Ayush, correct. So, as you know, metal has a tendency to lose electron, right? And that tendency is called oxidation, to lose electron. And lithium has a very highest tendency of losing the electron. It highly wants its outer shell electron to be loose and get rid of it. So when it loses the electron, it gets the potential of 3.04 volts. So that's why we are choosing the lithium as a primary material for the batteries. Okay.
and also it provides very high specific energy per weight, and it's highly reactive metal. So even if when it's in its purest form, it can even react with water like sodium. So that's how reactive it is. And here you can see with the help of this chart, here are the periodic table elements are there, and you can see lithium has a highest 304 standard electrochemical potential. So there are two things like oxidizing agent and reducing agent. So as I mentioned, oxidation is loss of electron and reduction is gain of electron. So elements which loses electron, they gets oxidized, and they when they are losing electron, other elements get reduced. So they itself undergo oxidation, and they make other elements go into the reduction. So that's why lithium is also called as a reducing agent, and it has a highest electrochemical potential. So because of all these reasons, we are using lithium as a primary element for battery. So now let's have a look at how now we have seen like why lithium is used as a battery material. Now we'll see how exactly the lithium ion cells work. Okay. So in any battery, there are, you can say, 5 key elements. So firstly, there is two electrodes. One is called cathode and one is called anode. Then there is electrolyte, separator, and current conductors. So there are 5 key elements of any battery. So we will see in lithium ion cell how exactly they work. Yeah. So this is the cathode. Cathode is a place where the lithium material is, we can say, placed. Or lithium is, we can say, spread on. So that's the cathode where lithium ion is placed. And there is a electrolyte. So this portion that you are seeing in light yellow, so this is the electrolyte, and this is a separator. So what separator does, it does not, it separates the cathode from the anode, and it prevents the internal short circuit. So through electrolyte, only positive ions can pass, and electrons has to pass through external circuit which is connected, and that's how we get the electricity. So what happens? Separator does not allow electrons to pass. So that's the key role of the separator. And anode is a material that keeps the active material, that is lithium material, entrapped when the battery is charged. So it has to hold the material in an unstable form. Okay, so what happens when lithium material is here? Let's say lithium iron phosphate chemistry if you are using. So lithium is here in a stable form and battery is not charged yet. What happens when we charge the battery? The lithium ion and lithium electrons, they get separated. Okay, and ions, they pass through electrolyte via separator and they get entrapped into the anode. Anode is majorly graphite most of the times. So they get placed inside the anode material, and the electron which is there, it has to pass through external path, and then they combine here. But at anode, they don't feel good enough to be here, and they are like unstable, and they want to be out of the anode as soon as possible. So that's the condition where battery is charged, or we can say fully charged. And when you connect any external source here, what happens? The electrons, they quickly try to follow the external path because they cannot go through this separator and electrolyte. So they go through that path, and the lithium ion, which can go through electrolyte and separator, they quickly follow this path. And that's how both of them meet here and the battery get discharged. So this is the construction and working of lithium ion cell. Hope you guys understood that. So when they are at cathode, at positive electrode, we can say. So in cathode, there is a T, right? And T makes the plus sign. So you can remember by this term that when there is a T, it's a positive electrode, cathode. And anode, there is a horizontal line of A. So with this, you can remember anode is negative. And this is how the general lithium ion cell or battery works. Okay, so let's move ahead. Let's talk about the construction or a specific cell that we have. So we all know the Tesla. They have been like they are the we can say pioneered in EV technology. So we'll how their cells work basically. So what as I mentioned, there are 5 basic parts of any cell. So this is the current collector. Copper is a current collector. Okay, and aluminium is a current collector. So one current collector at anode side, one current collector at cathode side. So on aluminium, we have placed the NCA, nickel cobalt material as a jelly. So what happens on a current collector, we spread the chemical, lithium chemical that is being used as a primary element for the battery. And on the copper anode side, we have graphite, which traps the lithium ions when it's charged. Battery is completely charged, and separator is there. So separator is generally made of polyethylene or polypropylene, and there is an electrolyte field in between, which is an organic salt of lithium, so that lithium ions can easily pass through it. So that's how the battery exactly, like internal structure of lithium ion cells look like. And they all these sheets, we have to, like, they are very thin micron level thickness they have, and they have to be rolled in a very specific and precise manner to develop one battery. So that also you can understand how sophisticated technology is required to manufacture one lithium ion cell. And there are like thousands of cells in a one specific electric vehicle. So you can imagine how complex the battery itself it is. So yeah, that was about the lithium ion cells. Now we'll talk about what are the different types of lithium ion cells are there. So there is not just one type. Lithium has to be used with other materials, okay, other metals. So it can be combined with cobalt and nickel, manganese, titanium, phosphate, aluminium, and chemical engineers have come up with multiple chemistries which gives the different types of outcomes or properties. So if we use lithium cobalt oxide, it gives the, so like there are multiple chemistries as I talked about. So we will see one by one what if we use this particular chemistry, what output properties we get from the lithium ion cell. So it gives the 3.6 volts of nominal voltage. So nominal voltage is like on average voltage of a battery, we can call it as. So I will just quickly show how the voltage characteristic of the battery looks like. So what happens? This is the time and this is the voltage. Okay. So when battery, we can say this is charge basically. So when battery is fully charged, 100% charged, at here we can say it's 100% charged. So it has a high voltage, but when it starts discharging, it slightly reduces and it becomes constant for a very long time. And when it reaches a certain rate of charge, it starts reducing. So this is the peak voltage of a battery, and this is the cutoff voltage. And the voltage at which it remains constant for a very long time is a nominal voltage. So this is what is mentioned here as a nominal voltage. So different cell chemistries give different nominal voltages. Most of them give 3.6 as a nominal voltage, but lithium titanate, it has a very low nominal voltage. So that's why this chemistry is not like preferred in most of the application. And specific energy also, you can see of lithium titanate has a very low specific energy, whereas NMC chemistry, which is widely used in India, various two-wheeler, three-wheeler applications. So the reason is it has a high specific energy. In a very small volume, it could store a lot amount of energy. And for charge, there is a C rate is there. So C rate is how quickly you charge the battery or how quickly you discharge the battery. So for charging, most of them have same charging 1C charge rate, but the output or discharge rate it varies in all of them. So you can see some of them can be discharged at 1C rate, and but lithium titanate can be discharged at 10C rate. So it can be discharged quickly when you require a high amount of power. You want to accelerate your vehicle very quickly. So if you are using lithium titanate, then your battery will discharge quickly and give a lot high amount of power at that specific time. So the discharge C rate is also different for different chemistries, and life cycle as well. So life cycle is what when you charge your vehicle 100% and you discharge it to the zero. So this completes one cycle. So and the numbers mentioned here are like these many times you can 100% charge your batteries and discharge your battery. So you can see here as well, lithium titanate wins the race. It has around 3,000 to 7,000 cycles of life, and based on all these properties which each of the chemistries give, we can decide which application we can use them in. So here we just mentioned the mobile and EVs. So in EVs, what we will prefer is that can be charged quickly and that can be discharged quickly and which has a high life cycle. So these chemistries are commonly used: NMC, LFP. LFP is lithium ion, ferrous, basically lithium ferrous phosphate, and lithium titanate oxide. So these three are majorly used in electric vehicle application because they fulfill the requirements that electric vehicle has. So the initial in the second slide that we saw what requirements EV battery has. So these are being fulfilled by these three major chemistries. And there are other chemistries as well which are under consideration and which has a balanced overall nature with like there are safety aspects as well which like we have to take care of. So out of these three, which is a safest chemistry, so that also we have to think of and then decide which can be put inside inside electric vehicle. Yeah, so this was about the different types and chemistries of lithium ion batteries and their properties and where they can be used. Hope you guys understood this thing. Okay, yeah, we shall move ahead. So now we understood about the lithium ion batteries, their working, their different chemistries and where they can be used. So now let's get to our next candidate, which is aluminium air battery. So yeah, can you guys just let me know what can aluminium batteries be if you have idea about something, or aluminium air battery, why it is there is an air term in it, how exactly it works, anything you know about it little bit.
We heard from latest news, this has been developed in Bangalore by Indian Institute of Science, and particularly this is since aluminum is very freely available and air is also available, we don't have to depend on import or anything. We don't have to depend on somebody else. This is what I think very little work has been done, and as far as the vehicle performance also, they have tried. There is a satisfactory result. Further trials are being done, I think, under development.
Yeah. Yes, Mr. Jain. Okay, so we'll see what aluminium air batteries, as we saw about lithium ion batteries, like internal construction of it, how exactly it works and what chemicals are used. So in aluminium air batteries also, we will get a quick look on how exactly it works. Okay, so this is the schematic of the battery. You can see in any battery, as I told, there is 5 major components: electrode, cathode, electrolyte, separator, and current collectors. So in aluminium air battery, aluminum itself acts as a current collector and the anode, and cathode is like majorly air has to pass through as a cathode, but to trap the air molecules, we have to use other materials like graphene and carbon nanotubes so that we can efficiently use the oxygen inside the air to be reacted with the aluminium. So that's why these other materials are used. And there is an electrolyte, aqueous electrolyte solution. So that aluminum ions can easily pass through it to be react, and they can react with the oxygen inside the air. And when what happens when aluminum comes in contact with air, we all we know where when we have aluminum components at our home and somewhere, so the aluminum, it gets corroded. How exactly it happens? When its layer is exposed to the external environment or air, it reacts with the oxygen inside the air, and it forms the layer of corrosion over it. And that's the process where aluminum loses the electron, and it undergoes the oxidation, as we were talking about initially. So same thing happens here. What we do, we intentionally put the aluminum in contact with air and create an environment where it reacts with the air, outside air. And what happens when it reacts? It loses electron. So electrons, they cannot pass through electrolyte. We select such materials that does not allow electrons to pass. So what electrons do, they try to find external path to be flown, and that's how we get the electricity generated from the external path. And when they reach cathode side, they combine and they form the aluminum oxide, and that's how the aluminum air battery works. So this is the very simple chemistry. There are no other types that we can say can be used. Just the different cathode material can be used, and different electrolytes can be used to fasten the reaction and to get the better output. So this is the general working of aluminum air battery. And now let's see the how it one property of aluminum which is advantageous at some point in some application is a disadvantage here as an application in a battery. So you all know when the nature of aluminum's corrosion layer that it forms is not very same as of the corrosion that iron gets formed. So the corrosion layer on the iron components, they are porous, and the corrosion, it penetrates inside the component, right? But the nature of aluminum corrosion is not non-porous. It stops the corrosion, and the layer which is formed over the aluminum, it does not allow more corrosion to happen, right? But here what we want aluminum to react with water to get energy, to react with air molecule to get energy. So the forming the layer of corrosion and preventing it from producing more corrosion, it will not result in a good performance of a battery. So what we have to do, here you see the property which is a good thing, advantage when you're using aluminum as a specific different component or a product, there this property is advantage because it's we can say preventing the further corrosion. But when you are using this aluminum in a battery, this property is becoming disadvantage because we want aluminum to get corroded and we want it to be reacted with the oxygen. Then only we will get the flow of electron. So to prevent this, what we do, we apply the layer of carbon over the aluminum strip that we are using as an anode. So what happens? This carbon layer does not allow corrosion to be formed here, and whatever the aluminate gel or the corrosion is being formed, it gets disposed and it gets accumulated from the bottom. So that's how we prevent the stopping of more oxidation. So we want oxidation to happen continuously. So that's how we prevent it. And what happens when the complete aluminum is being used, so the reaction stops and we cannot use it further. So that's how the aluminum air battery works. So this is the strip of aluminum. There is an electrolyte surrounded by it, and the air comes in contact from the cathode end, and that's how we get the electron into the external circuit. And it's very easy to make your own aluminum air battery. Then you can do this experiment at your home itself. It's not very hazardous or harmful. You can perform it at your home. So you just require 2-3 things. Okay, you have to have aluminum foil. Okay, the aluminum foil that we generally have at our home to pack our food. Then what you have to do, you have to take a paper towel or tissue paper and dip it inside a salty water, just a little, like, dip it and remove it and place it over the aluminum foil, and over it you have to put the charcoal, activated charcoal. So the activated charcoal, you might find it on an aquarium shop. It's used to filter the water and all. So there you will find the activated charcoal. So what it does, it catches the air from the oxygen from the environment, and it can be used as a cathode material. Okay. So what you can do is take one small bulb, okay, and connect one end to this foil and connect another end, insert that into the charcoal, and before inserting it, also like make it wet with the help of that salty water that you dip the towel into. So that's how the current will easily flow, and you can see the bulb that you are used will light up, or if you are using a small motor, so it will start rotating. So it generates around that sort of millivolts of voltage, which is sufficient to light the bulb. So this is a very easy experiment you could perform on your own to see the working of aluminum air batteries. So yeah, did you guys understood this? Shall we move ahead with another concept of aluminum air battery?
Yes.
Okay, cool. And I hope you guys will try out this small experiment at your home. It's not much costly or something. It's a very easy and quick thing. Okay, sure. So let's move ahead and talk about the aluminum air battery. Like, what is the development stage? We know lithium-ion batteries like the Panasonic, LG Chem, then CART, and different there are a lot of manufacturers in the market who are developing lithium-ion batteries. Okay, so we see Eveready, Duracell, so many things, so many companies are making those things. But what about aluminum ion batteries? Have you ever seen any manufacturer who is developing at a mass level of aluminum air batteries? Has anyone heard these batteries are being manufactured by this particular company?
Is this invention has started in India or somewhere else?
No, it was invented up like quite long back, and this battery has been in application for a quite long time, like 30, 40, maybe 50, 60 years ago. It's in application, but it's not being used for an electric vehicle application. But now we're thinking of putting it into the electric vehicle. So yeah, that's the thing, and we'll talk more about that.
Sir, Log9 is using this battery.
Yeah, Log9, exactly. So they are very much researching about all the types. And recently they have launched there's new battery in-house, like manufactured inside the India and all. So yeah, they are one of them who were working on the prototype of, but they didn't mass produced it anywhere, aluminum air batteries.
Yes, sir. It's been around 4 years.
Okay, so yeah, let's move ahead. So we'll see how exactly the construction, like how exactly it looks like. We know lithium-ion cells, how they look like. We have seen internal structure of that. But now let's see how exactly the construction, physical presence or exploded view you can see here on the screen for the aluminum air battery. So you can see there is an aluminum plate here, which immediately after that, there is a separator. And then there is a cathode. And cathode is, as we discussed, it's made up of some sort of carbon material or nickel sometimes. And there is a passage of air, like the holes and vents are provided to let the air in. And it reacts with the aluminum in presence of electrolyte. And the current collectors are there on the both ends. So here, this is a current collector. one current collector, and at aluminium end there is again one current collector. So whatever chemical reactions happen in between the anode and cathode, so whatever current is being flowed, so these collectors collect it and give the path to be flown from the external circuit. So, and this is all this setup is enclosed in some insulated material, which is majorly uh, we can say a plastic or polymeric material. So that's how the physical structure of aluminium air battery looks like. Okay, so now let's talk about the advantages of aluminum air battery. How, like, what advantages it brings to us, and how it can compete with the existing lithium ion batteries. Okay, so first major advantage of having aluminum air batteries is aluminum is very cheap and it's very easily available in India. Okay, so we have a lot of resources of aluminium in India, whether and while on the other hand, the lithium resources are very limited to specific region in the world. So that advantage we have, that we can extract the aluminium very easily. It's reachable, and the technology to extract that and to filter that out and get the pure aluminium is also is very advanced as of now, because it's been for a long time. So we can say that's one of the key advantage that aluminum air battery has. And again, there is a lightweightedness of aluminium. So we all know it's very light when it comes to the metals. We are replacing all the steel and iron components of mechanical structures with the aluminum. Why? Because it gives lightweight and the same a good strength in that particular application. So that's why lightweightedness is also one thing. And another material that it uses is air and water, so which is also easily available. There is no like difficulty in finding it. And not last thing, but it's non-toxic. Any chemical which is being used here is of completely non-toxic nature, and the chemicals which are used in other battery chemistries, they might harm the human body in some or the other way. So that's the another advantage. We can easily use aluminum air batteries. Okay, and the for aluminium, if we know that when aluminum is completely consumed, we cannot charge it again. We have to recycle the aluminium which is present inside the battery. So recycling technology is also easily available nowadays. Whatever components we have, we can aluminium can be easily recycled. So that technology we already have. So these many advantages aluminum air battery comes with. Yeah, so now let's jump to how the market is going on when it comes to the aluminum air batteries. Who is making this, and what is the future of this aluminum air batteries in India? Because we saw that aluminum is very easily available in India, and we have a lot of resources of it. So we can think of being, we can say, major player India, being a supplier all over the world of aluminum air batteries. We can consider that thing because we have a lot of resources of aluminum. So let's see what is the current condition of Indian market when it comes to aluminum air batteries. So we all know Indian Oil. They have been into crude oil and all. So they have collaborated, or we can say they have joint ventured with some another foreign company to do research and the development of aluminum air battery. And if those research experiments they get successful, they will start the mass producing it with the help of the technology that startup from the foreign has developed. So do you guys have any idea what is the name of the company which Indian Oil has collaborated with or has a joint venture with? Just checking your current affairs and general knowledge.
Is it a Reliance?
No, it's some foreign company, not Indian company.
Foreign company, okay.
Okay, so let me tell you. So it's a Finergy. Finergy is a style-based company, and it's founded in 2013. And since then, they have been doing research on these aluminum air batteries, and they claim that they have got around 1,000 miles of range when they used aluminum air battery in an electric vehicle. So you can see 1,000 miles is approximately 1,600 and something kilometers. So that's a huge thing which none of the EV has achieved yet. So it will be a great thing if we can have such a huge range in electric vehicle to reduce the range anxiety in the customers. So they have good research and manufacturing technologies, and you can say so these things they already did from 2013. So it's almost 10 years research and development they have. So Indian Oil is supporting them with the joint venture that they did. And what they will be doing is they will be, firstly, they are now they are on the research and development stage in India, Indian climatic conditions and Indian vehicles and all. And once these tests are successful, then they will mass produce it. So here you can see.
Of the world, where is this Finergy?
Yeah, they are based from Israel.
Where?
Israel.
Israel. Okay.
Yeah,
Okay.
the Israel-based startup.
Israel is good with India.
Mm-hmm.
Our relations are very good.
Mm-hmm. Yeah, so that's why they collaborated with them. And here you can see they have installed the aluminum air battery packs at the boot of the vehicle, and they achieved that 1,000 mile range. And when they are in India, researching and developing, so Mahindra they took initiative to give them their vehicle for a tasting. So Mahindra was working on their electric three-wheeler Atrio, so which runs on basically lithium-ion batteries, but they have given them some samples to run their aluminum air batteries and perform tests on that. And here you can see the people from Finergy and Mahindra, they are like tested their vehicle, and they didn't disclose the exact results of it. And apart from Mahindra, Maruti Suzuki, Ashok Leyland, these companies are also testing their vehicles for Finergy's developed aluminum air batteries. And once these results are out, so we'll see what decision they take, whether to go for mass producing of these aluminum air batteries or not. Okay, but there is a big but that whenever there is a new technology comes in, and whenever we think of shifting from one technology to another technology, there are challenges that we have to come up with. And that's what we engineers are for. So now let's see what are the challenges that aluminum air battery brings. We saw the advantages of it, how it is good to be used in electric vehicle, but what challenges it has, that we will see now. Okay, so the first challenge and very major challenge is it's a primary battery. So do you know there are two different types of batteries? One is primary and secondary. So what is the difference between them? What is the primary and what is secondary?
Non-rechargeable.
Exactly, Sanjay. So the primary batteries that we cannot charge them again, and secondary batteries which can be charged. So lithium-ion batteries, they are secondary batteries. We can charge them again and again. But the aluminum air battery, it's a primary battery. When you use it, it's used up. You cannot use it again. You cannot recharge it again. So it's not a good thing to we are not being able to charge the battery again. So now you have to imagine if there is a battery, there is an electric vehicle which is installed with aluminum air batteries completely, so there won't be a charging port anywhere. So imagine a vehicle without any gate to be fueling or charging anywhere. So that's the challenge that aluminum air battery has. Once it's discharged, you have to take the complete battery out. But we have to come up with a solution that we won't have to get the entire battery out of the vehicle, because batteries are bulkier and there are huge amount of battery inside a vehicle. You cannot remove the entire battery in a one. So what we have to do is what happens, only the part which is being used out, which is the aluminium only, right? The anode of the battery. So what we have to do, we have to design battery in a way that it's easily, we can say, we can easily put the aluminium in and easily put the consumed electrode out. So that's how we have to design in a way that we can easily swap the aluminium anywhere. So whenever we are using this particular battery, we will have to have such infrastructure that we cannot charge this battery, but we can swap the aluminium electrodes which is being used. And we have to come up with a very easy and quick mechanism that won't take a long time. Like charging electric vehicle, it takes 4 to 6 hours, something like that. But swapping, if we make it easy and quick, that all the battery electrodes can be swapped easily within 30 minutes or 40 minutes or maximum 1 hour, and we can get a range of 600, 700 kilometers. So yeah, it will like it will be a very amazing thing in an electric vehicle market that exactly the consumers are looking for. So that's the challenge aluminum air battery has, that it has a consumable electrode. And the solution to that is we have to design an infrastructure and a mechanism that we can easily swap that electrode. Okay, and after swapping that electrode, what we have to do is we have to recycle. Okay, recycle, like the electrode has been completely consumed, so we have to deliver it to some places, and it will, like, they will do the processing and we will get the pure aluminium that can be used again. And one more thing here is like the extraction of aluminium and recycling. So this process itself consumes a lot of energy, and if that energy is being developed by the conventional source of energy, like from the thermal power plants and from the natural gases and oil and all. So what's the mean of using these batteries here? Because if you are not polluting in the city, you are polluting somewhere else, and in any way it's harming the environment. So what the solution is, whatever the process is being used to extract the aluminium and to recycle these electrodes, the energy is, whatever energy is used, it has to be coming up from the renewable sources of energy, which does not harm the environment and which does not pollute the environment. Then only using this battery will make sense. Otherwise, you are not polluting environment from your car, but you are polluting drastically from the plants where you are extracting and recycling these batteries. So that won't make sense. So these are the challenges that if we come up with these things, surely this can beat the lithium-ion batteries, which for which we have to be dependent on other countries. And aluminum air battery, in this technology, we can be a world leaders because we have a huge resources of aluminium and the technology to extract and filter it out. And if I wish if this the trials and tests that these companies are doing, they get successful, and we get the suitable infrastructure ready to adopt this technology. Okay. So I guess it's almost 5. We will quickly compare what are the properties of different aluminum air battery and lithium ion battery. So temperature range that lithium-ion battery can be operated is -40 to 45 degrees. But there is in between this, there is again the optimum range, like from -5 degree to 25-30 degrees, in which it gives the best performance. But aluminum air battery, its range is more wider. It can be used in -60 degree to +80 degrees itself. So you can see here also the aluminum air batteries are advantages. Then anti-abuse ability. So means when they are exposed to different abuse conditions like thermal abuse or mechanical abuse or something like that. So lithium-ion batteries are more likely to be catching fire or burning out or something. But aluminum batteries, they don't have those sort of chemicals and that kind of end reaction. So in that term as well, aluminum air batteries are better. And energy density also we talk about. So it's quite similar as compared to lithium-ion batteries. and the power density, like how quickly they deliver the power. So aluminum air battery are like they are very good in terms of power density. And consistency means if we keep the battery at one place for a long time, by long time I mean 10, 20 years or decades. So if you keep a lithium ion battery for a very long time, it will discharge completely and maybe it won't work even after that long period. But aluminum air batteries, until and unless you expose aluminum to air or oxygen, it can last for decades or centuries. So that's how you just have to we can say prevent the oxygen in being contact, aluminum in being contact with the oxygen, and you can have a very long shelf life of the battery. And the fabrication or manufacturing process, if you call it as, so you have seen the cut section of the lithium ion battery, how difficult it is to form those very thin sheets of copper, aluminum, and spread the entire active material on it, then separator. So it's very sophisticated and complex technology. But when it comes to aluminum battery, there is no much, like it's there, definitely it's not very easy thing, but as compared to lithium ion, it's not that difficult. And charging speed, so lithium ion battery, as they are secondary cells, so they needs to be charged, and charging time is more, as we know. But yeah, the researchers have worked on it, and they have achieved a very quick charging as of now, definitely. But aluminum air batteries, if we come up with a quick swapping mechanism or quick swapping technology, so it will surely beat the charging speed or refueling time of for the battery. And in terms of safety, as we discussed, lithium-ion batteries, we all have seen a lot of incidents happened recently when like properly tested batteries have been used in vehicles. So these kind of safety issues are there with lithium ion, but there are no such incidents that can probably be happening with the aluminum air batteries. So here we see that aluminum air battery is we can say it's competing with the lithium ion battery in any manner we call. So we can think about it to be used in electric vehicles. But challenges we already discussed. And let's have a quick look on the lithium ion batteries limitations. So lithium ion battery, the raw material is hard to find. It's not evenly distributed over the earth. So we have to be dependent on other countries to get the raw material. Then extraction and making of the batteries is definitely, we already discussed that it's difficult. And storage. So storage, as we saw, that it catches fire sometime and it could be hazardous. So that's the thing. And recycling of lithium ion batteries. So for information, we are using so many like all over the world, whatever number of batteries are being used, less than 5% of that is being recycled now. Rest 95% is being abundantly thrown in the environment, and they are like putting a very bad impact on the soil and anywhere they are being disposed. So you can imagine how, like, we are trying to be a clean energy, we are trying to find the green energy solution, but we are ending up with harming the environment in another way. So that's the thing. But in case of aluminum air battery, you can recycle it, and if you are using renewable energy, then the recycling makes sense. Otherwise, that also is the same thing. So yeah, that was the quick limitations of lithium ion batteries. So now I would like you guys to tell me what are your views on this comparison, and what you conclude out of this session, which battery you would like to put in your vehicle, what the things that you got but I couldn't get, and what limitations you think that could be constrained to adoption of aluminum air batteries in India.
I think aluminum batteries are still in the study and research stage. Probably the experts like Toyota, Tesla, all these fellows would have done already some work, but still they are pitching upon lithium. There could be some limitation as far as the technology is concerned, particularly swapping technology, putting the electrodes in place of used electrodes. And also, I have seen there is no much supporting statements as far as the government is also concerned on this aluminum air batteries. I have not seen. Maybe I may be wrong also, but some solution will be there. Nothing is impossible in this world, but it may take some more longer time to get into these challenges what you have listed down.
Yeah, definitely. And like these, as I mentioned, these batteries have been there for a long time, but now we are thinking of it making in to the electric vehicle. But
where was this aluminum?
Yeah, so they are being
battery
used
production?
for military purpose and some sort of communication purpose, and the places where there is less reach of electricity, like supplying the electricity there would cost much. So there we have put the, to run those systems, we have put the aluminum air batteries. As we saw one of the property of it, that it has a very long shelf life.
Long
It does
storage.
not consume get consumed when it's kept for a decade, even for a decade. So for the regions where military, they have set up some sort of confidential systems, they have used aluminum air batteries because it does not get consumed quickly. So
Very
for
good.
these kind of applications, it has been used.
True this.
Mm-hmm.
Very nice overview. Now it is you are asking us now our views. We can only wait and see, and we need a support from all young engineers in the institutes, colleges, the faculty member to take up such type of innovation and support with their papers, publications to manufacturers in a small way.
Mm-hmm.
That is my suggestion.
Yeah.
Thank you all. Thank you all very much.
Okay. So students, there, like when there is a new technology, what happens? We don't directly use that 100% in any place. So like in electric vehicles, we firstly shifted to hybrid technology. We introduced some little amount of battery inside the vehicle, and then we are completely getting battery electric vehicle, fully battery electric vehicle. So here also what we can do, and another example I could give is of biofuel. We cannot directly use the biofuel inside the vehicle. What we do, we blend it with the conventional diesel. So biodiesel, it's blended in a certain percentage with the conventional diesel, and then we can use it. So that's the way we can use the aluminum air batteries as well. So there will be one main battery, which will be a lithium ion battery, and another auxiliary battery can be used, or support your supplementary battery can be there, which will be aluminum air battery. So when we get all the lithium ion battery consumed, we can use aluminum air battery at that time to reach to the power station and to reach the charging station. So
It's a very good suggestion.
Yeah, that
Very
kind
good
of
suggestion, alternative way.
yeah. And why we are
Cost should
saying
not go up.
yeah,
Cost
and why
should go for Indian applications.
And why I'm saying lithium ion battery as a primary and aluminum as a secondary, because aluminum battery can be, they does not discharge on by itself very quickly. That's why we can have them as a placed for a long time not being used. But as we have a requirement, we see that our vehicle will be completely discharged in a very quick like a very short time. So we can shift on aluminum air, and we can reach to the nearest charging station. That's how this technology can help, and slowly we can adopt it in our electric vehicle environment or electric vehicle scenario. Yeah. So hope you guys enjoyed this session. Let's revise quickly. We saw about the batteries. What is them? They are energy storage devices. Different types of energy storage devices are there. Then why we are using lithium as a component major component in battery. Its electrochemical potential is there. Then we saw different types and properties where they can be used. And we talked about aluminum air batteries, how they work, what is the construction. We saw the exploded view of it, how it's placed, aluminum, cathode, electrode, and all such things. What are the advantages aluminum air battery has? What challenges it brings to us that we can try to find out the solutions for to be a world leader in aluminum air battery technology. And we saw the comparison of both the things, how exactly like they differentiate from each other, and some limitations of lithium ion batteries. We saw that the aluminum air battery overcomes. So that's about the today's session. So I really appreciate you guys attending today's session. And as you attended this session, there is one surprise for you guys that I'm putting one link in the chat box. So you have to fill up this particular form. And after filling this form, there is like, while you're filling this form, you will find 4 or 5 options which field knowledge you want to learn and which domain you want to learn about. You can select them, whether it's mechanical engineering, electrical engineering, anything, and fill in that form, and you will get the counseling from us, and you will get the access for a free to learn some concept of that particular domain. And 25% of you who will finish the entire course earliest, they will get the certificate for learning that particular thing. So yeah, go through the link in the chat box and fill out the form, and enjoy learning in a free, like this session today. Okay, so hope you enjoyed today's session. Please feel free to ask any doubts if there, or any discussion you want to make. And before completely wrapping up the session, I heartily thanks Vasireddy Venkatadari Institute of Technology and Mr. Satyanarayan to being for arranging this session for the students of the college. Thank you very much, sir.
Which place?
Thank you, Mr. Rahad. And also I thank Mr. Jayanna for making this discussion very lively and very interactive. And I hope our students are... Sir, Jayanna, sir, thank you.
You are from which place?
I am from Guntur, Andhra Pradesh. I am Dr. Satyanarayana, HOD of Mechanical Engineering here in VVIT, Vasireddy Venkatadari Institute of Technology.
Yeah, please share your contacts, sir. I will get in touch with you. మీకు తెలుగు కదా?
తెలుగు వాళ్ళే సార్ మేము.
తెలుగులో మాట్లాడదాం.
అంటే అదర్ పీపుల్ ఉన్నారు కదా, అందుకని ఇంగ్లీష్ లో మాట్లాడుతున్నాం అంతే.
ఓకే ఓకే, ప్లీజ్ షేర్. ఐ హావ్ గివెన్ మై కాంటాక్ట్స్ ఇన్ దట్ thing. I am only sharing my experiences. I should really thank Mr. Shaikh. I have Shaikh, a very nice way of
Thank you very
sharing
much.
information.
Thank you very much.
One more request, Mr. Rahad.
Yes, sir.
Our BTech students are doing some project on electrical vehicle. Sometime if they want some help, can you come forward to help them?
Sure. You could reach out to me over the LinkedIn via ITG's page, and there if you drop a message that for this particular reason you need my help, I will surely revert back over there.
Definitely. Thank you, Mr. Rahad.
Yeah, thank you, Mr. Dr. Satyanarayan.
And thank you, ETG team.
Yes, welcome.
Thank you all. Bye.
Yeah. Okay, sure. Students, if you have any doubt discussion, I am here for 2 more minutes.
Sir, good evening, sir.
Yeah, Venu, good evening.
Sir, we hear that some of the two-wheelers are firing. Some of the two-wheeler electric vehicles are firing while charging. What is the reason behind that, sir?
So basically, the electric vehicles are like not toys. Basically, they has to be taken seriously as a product. So it's not recommended to bring the vehicle inside the house when you are charging. There are some safety protocols that has to be considered, and like at customer ends itself, we shouldn't be careless, and as well as from the manufacturers aspect, if we see, so they also have to do a lot of research and development. What most of the recent manufacturers they have done, they have just re-engineered the product which are there in the other countries, and they were designed for that specific region, for their climatic condition, for their temperature ranges. But when it comes to India, it's completely different, and the temperatures, the climatic conditions here, they are very different from other countries. You cannot have same product being run on the Indian roads, and as well as the testing and trials has to be done multiple times, so and in different conditions with different we can say different abuse states are there. There are a lot of tests that has to be performed on the batteries, and now everyone is being serious about this because it's it's a turning point of EV industry, and if such scenarios happen, so we cannot get this done quickly, and we cannot easily shift to electric vehicles, and we won't be in a condition to save our environment in future.
Good evening, sir. I am Abdur Rashid Beg here.
Yeah.
Sir, I have a question that I recently read an article about the Ola electric vehicle S1 Pro something like model, and it has the customer that the guy who has bought the vehicle has written that the one vehicle he has charged to 100%. It shows the climate of some kilometers, and it's it is getting suddenly dropped to some like multiple getting reduced to 50% or below, and after some kilometers it's getting stopped. Why these batteries are such a weak batteries to keep the charge, or what is the problem, sir? So it is getting discharged very quickly.
So what is there? There are two aspects of electric vehicle. As it's electric vehicle, there is a hardware aspect and there is a software aspect. And the backbone of any battery which is being used in electric vehicle is a battery management system. So battery management system, it has to read the what we can say, the properties of each and every cell which is there, state of each and every cell, what voltage it's at, and what is the charging rate it has, charge capacity it has. BMS has to be designed and tested for like multiple times, and when it's not functioning at good functioning at a hardware level, its sensors are not that good enough, and even if the sensors are good enough, the software which is used has bugs and is not tested for various conditions. So that's why that's the reason this kind of we can say incidents happens. So the intense testing and validation process has to be given to these things.
Sir, another my doubt is that so we have if you know we are using IC engines in our two-wheelers or four-wheelers. Now we are and leaving our house without a checking of any fuel, or because we have a multiple fuel outlets here, and the time to fill the fuel is very less. Just to check just minutes hardly.
Yeah.
So the electric vehicle is just taking hours together to charge. Can't we improve that? Can't we reduce the time to charge or something like that? Because if we have to generalize the electrical vehicles, we have to, the main concern to buy the electrical vehicle is the charging time it's taking and the range it is getting covered. The range can be increased by increasing capacity, but the charging time is getting reduced. Is there any special type of batteries to reduce the charging time and increase the range, sir?
Definitely. Like recently, if you see in between session also we talked about Log9 materials. So they have come up with the battery technology that charges very quickly. Within 1 minute, you get a like high amount of charge. I don't exactly remember the figures now, but if you see, they have recently within past 2-3 weeks itself, they launched their new battery. So there has been a lot of research and development going on in terms of charging the batteries quickly, and other chemistries also the engineers are looking for which can be quickly charged. And there is a battery swapping technology. The government is also supporting that initiative for the swapping. It's very quick rather than being waiting for the charging, you could just quickly swap your battery with the charged one. So that drastically reduces the refueling time. So that's also the concept, but it requires a very good infrastructure to be set up at different places for the swapping technology. Okay.
ಗೀತಾ ನಾನು ಹೋಗಿ ಬರ್ತೀನಿ ಫೋನ್ ಮಾಡ್ತೀನಿ.
Okay, students, I guess we talked a lot in today's session. It's almost 5:20. And I really thank you guys for patiently listening and asking questions, doubts, answering my questions, and taking part in the discussion. I really appreciate you guys. Okay. Thank you. Thank you very much for attending this session. Keep learning, keep exploring. And once again, I'm reminding you to go through the link in the chat box, fill out the form, and get access to the course for free. And 25% of you who finishes the course earlier would get the certificates. Thank you very much again. Bye everyone. Have a nice
Thank you very much.
Yes, thank you.
Thank you, Sheikh. Thank you very much.
Yes, sir. Goodbye.